if we want to do that, we want, so for this function right here, we want to be able to write it, we want the third degree Taylor polynomial for it. We want P3x. How do we go about doing that? Find the what?
Like you find P of x and P prime.
So yeah, okay, so take lots of derivatives is what you're saying?
Yes.
So ln of 1 plus x. So what's f prime of x? What is it? Oh, it's 1 plus x to the negative 1. Well said. Like that? What's f double prime of x? Negative 1 plus x to the what? And then what's f triple? Let's do a few of them. F triple prime is going to be what? 2, 1 plus x to the negative 3. So how far do we need to go?
I did 4 because you're going to need it later.
You're going to need it later, yeah. So if you do f4, so you can always not use them, but if it's pretty easy, you might as well. You end up with negative 6, 1 plus x to the what? Negative 4, right. So then what do you always put next to this? What do we compute over here? What have we done a few times? Plug in what? Plug in 0. So what's f of 0? 0, yep. ln of 1 is, yep. So what's f prime of 0? What's that going to be? 1. F double prime of 0 is going to be what? F triple prime of 0 is going to be 2. And f the fourth is going to be negative 6. Nice. So then you need to then do what? So therefore you know that P3 of x, what's the first term? 0, because that's f of 0, right? Plus what? 1 over 1 factorial x to the first plus negative 1 over what? 2 factorial x what? Squared. And then what?
2 over 3 factorial x cubed.
X cubed, yep.
Yeah, but that's all we need because that's only 3.
Ah, okay, excellent, okay. So do we have what we need? That's what we just determined, right? Yeah. Is everybody with me so far? Yeah. We just came up with an estimate for ln of 1 plus x as a Taylor polynomial, third degree, right? So if we wanted to, what does it say? We're trying to estimate this value. How do we go about estimating this value? What do we do? What do we plug in? No, if we wanted to use this to estimate ln of 1.5, what do we plug in? You do not plug in 1.5. Be careful. Look, we're estimating ln of 1.5, so we need ln of 1 plus a half. You plug in a half for x. You have to be very careful about that. You have to be super careful about that. We use ln of 1 plus x as our estimation, or the function we're basing our Taylor polynomial on. So if we're estimating ln of 1.5, the 1 is already there inside the function. So if we do this out, this is going to equal, and you can do it out by yourself. Can someone remind me what that big phrase is? M over what? N plus 1 what? Factorial. So we have m over, what was it? N plus 1 factorial times what? Absolute to the what? N plus 1. In this case, what does n equal? 3. And I'll let this stay there for a second. I'm going to put a question mark there. But what was the key thing about m? What is m? F to the what? Do you remember? N plus 1th derivative, right? Has to be what? Less than or equal to m, like that. Okay, so in this case, what's the n value? The n is 3, right? So let's fill in what we know. We're like, okay, so we have m over 4 factorial x minus a to the 4th. So now what are you asking yourself? What do we need to find here? What are we centering it around? A is what we centered the Taylor polynomial around. The question is, what did we center it around? How do we know we centered it around 0? Well, A told us to, but like if we look at this, if we looked at that Taylor polynomial, how is it obvious that it's centered around 0?
There's no C.
There's no what?
C.
There is no A. Well, there is an A in there. What is A?
0.
It's 0. What's being subtracted from x? 0. So we're centering it around. In this case, A is 0. So what do we have here? We have this right here. Okay, that's nice. So now we need to find. I like what you went to the key element when I asked you this about 3-4 minutes ago. What are we searching for? M. It's the search for m. So to search for m, what do we need to calculate? We need to calculate the nth plus 1 derivative, which is what Pinky pointed out we would need. So up here, we went to, did we use the fourth derivative yet?
No.
We haven't used it, but what do we have for the fourth derivative right here?
-6.
Hold on. Well, yeah, evaluated at 0, but yes, but hold on. So the fourth derivative in this case is that thing right there, correct? And we want to know what's the maximum value that that function takes on a specific interval. What interval do we look at to figure that out? 0 to what? 0 to 0.5. Yeah, so we want to find the max on the interval 0 to 0.5. Why 0 to 0.5? Because you're going from what to what? In the definition, it tells you to go from x to a, right? In this case, what is a? 0. And what did we plug in to get this value? What did we plug in? We plugged in a half. So that half is right there, and the a value, what we centered around, is 0. So now we look at this function, and now we just do a function analysis and say, this function right here, what happens to this function from 0 to a half? Does it get smaller? Does it get smaller? So what do you plug in to make this a maximum?
0.
So plug in 0. Are you everybody with me so far on that? It's always going down. So the max happens when what? When x is equal to 0. So when x is equal to 0, what do you end up with?
-6.
-6?
Yeah.
So you do this all out, and yes, you end up with p3x of this thing is equal to 1 minus 1/3 x minus 1/9 x squared minus 5 over 81, right? X cubed? Yes. Nice.
Why isn't it 5 over 2 factorial?
You can, at this point, not right now, wait and check your algebra later, everybody. I don't want to check your algebra right now. We're doing this at a slightly accelerated pace. But if you do all of the algebra correctly, and I don't have time to check all your algebra right now, that's what you end up with. I'm just telling you right now. Check it later. Walk away from it. The algebra, you have to be very careful. You're just differentiating and plugging things in. Be very, very careful. What we're trying to find now is, what is E3? That's what we're trying to find. We're trying to find E3. And E3 is the actual function value. Now here's the thing. What do we plug into this function to get this? What do we plug in? What's x going to be here? What value do we plug in? Exactly. So it's going to be f of 0.5 minus p3 at 0.5, which we can now find out. We know that that's going to be less than or equal to m, right? Over what factorial? In this case, what does n equal? 3. It didn't change, so it's going to be n over what? 4 factorial, right? And it's going to be x minus 0 to the what? 4th. In this case, x is what? 1/2, like that. Is everybody with me so far? So now, as you've done before, we're just searching for m. In order to find m, though, we need to find the which derivative. We need f what? F4. Did anybody find F4? Yeah. F4 of x? Anybody have it? F4? Is it negative 80 over 81?
Yeah. And then 1 minus x to the 11, negative 11 over 3.
Negative, thank you, yeah, okay. Is it this one right here? Negative 11 over 3, like this?
Yeah.
Thank you, just want to make sure, thank you. Again, catastrophic failure because we're dealing with very small decimals and big numbers all at the same time. So we want to know, where is that number maximized on what interval? What's the interval? Can I hold? Happens where? Happens when x is equal to 1/2. How do you know that? Times 2 to the what power? Bless you.
Thank you.
2 to the what? 2 to the 11/3, right there. So remember how we got to choose nice m values before? The m values were like 2. The m values were like 5. The problem is here, is there any good logical way to make? Not really. Like, we want to keep it there. So that is our m value for right now. So unfortunately, where do we have to put that? So now we know that the error 3, remember this from above here? I wrote it right. Where did I write it? I thought I wrote it. Yeah, there it is. This is the error we're looking for right here, which is this right here, is going to be less than or equal to, ready? 80 over 81 times 2 to the 11/3, all over what?
4 factorial.
4 factorial. Nice.
X to the 4th.
Times what?
X.
1/2 to the, so yes, and this would be E3 at, if we want to do this properly, it would be E3 at what? E3, come on, give me the pen back. Ugh, come on. I want you to come out with that. Like, if I wanted a decimal, what would you need to use? Use your calculator right now and tell me what's really the only thing you're checking when you find these two values.
Make sure that that one is bigger than that one.
Correct, because this right here is the max error, and this one is the actual error. This